Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 28, Acids and Bases, Part 2. Here are our objectives for today's video. Pause here. So some substances can act both as acids and as bases. Water is a perfect example as this. Water is approximately just as good of an acid as it is a base. Not all amphoteric substances are like that. Ammonia is like that, but it's a much better base than it is acid. But we're just going to focus on water. So you can have two water molecules that interact with one another and then chemically react to form H3O plus and OH minus. And this is a pretty well-known reaction at 25 degrees Celsius. The equilibrium constant for this is known to be 10 to the negative 14th power. And since 25 degrees Celsius is room temperature, this is going to make doing some math with pH and pOH very, very convenient. Pause here. So the pH scale is used to measure acidity or basicity as well of dilute aqueous solutions. So we've got pH, which is equal to the negative log of H3O plus, which you can use interchangeably with H plus if you haven't already realized that. There's also pOH, which is just negative log of the OH minus concentration. So the reason why I say dilute aqueous solutions is because you can, of course, plug in values that will get you things that are outside of the range of 0 to 14. And at that point, a pH meter just doesn't do a very good job anymore. So it doesn't really make sense to use the pH scale outside of the spectrum of 0 to 14. So we're going to use it for dilute aqueous solutions. So this will not work if you have 16 molar sulfuric acid. Pause here. So we can use the fact that Kw is known to be 10 to the negative 14th power and make things a little bit easier for us mathematically. So pKw, which is just the negative log of Kw, is equal to pH plus pOH, which all that means is that pH plus pOH is equal to 14. You don't really need to worry about sig figs too much with these sort of problems. I just tend to keep it consistent with how many are in the problem. Pause here. All right, so I just put this up here just to make my life a little bit easier. And then it doesn't actually matter which of these two equations I use. I'm just going to use the second one because I think it's easier. Right, and then same sort of thing for the other one. Pause here. So I'm going to do this one the other way just so that you can have seen it, but I could continue doing it the other way as well, the way I did the other example. I just want you to have seen this. Here are the practice problems for today's video. Thank you so much for watching and have a great night.